And if the area to the left is 0.7500, we get excited because that's what we can just go and look up, okay? So what we're going to do is we're going to look at our chart to see how close we can get to 75% of our graph being shaded. What value do you guys find? What's the closest to 0.7500 in here? I think it's the lower one. I think it's the 7486 because that's 14 off, okay? And that one's pretty close. So 7517 was going to be 17 over. 7486, 14 under. So that's our winner, 7486. But that goes with a z-score of what would we say, 67? Guys, again, this z-score, you're like, it doesn't make any sense to me, and it won't. But he's going to be our middleman because eventually we're going to be able to use that z-score to work backwards and say, oh, to be in the top 25% of this physical fitness test, you need to run the mile in 7 minutes or whatever. You know what I mean? So he's just going to be our middleman. We just have to realize we're working backwards. All right, so that is like kind of the last concept. So the next chunk of 7.2, guys, is just putting it into action. How can we use this backward concept to find actual everyday normal values? So let's look at it. So it says, now let's put it to use solving problems. The inverse of the z-score, and you do not have to write this, I'm just telling you where this is coming from. So what we're going to do is before we were given an x, mu, and sigma, and we could plug it in to find z, which we use as a chart, okay? Now we're going to be given an area, which is going to allow us to find z, and we don't know x. So think about how you would solve for x. What would be the first move you'd make? You'd multiply each side by sigma, which would get rid of sigma here, but it would leave you with a z times sigma there. And then the next thing to get x by itself is you would add mu over. So guys, this is not really a new formula. It's actually your z-score formula solved for x. Okay, it's just your z-score formula solved for x. But you will want to highlight it or circle it or square it or something because that is your formula you're going to use for I call them the backwards problems, when they give you the percent and you have to work backwards. All right, so how are we going to do this? We're going to shade the desired area to compute x. We're going to find the z-score using that area, which is our middleman, and at that point we can plug it into our formula and get the answer, okay? So again, even though this is probably the more complicated and less used in stats, I think it's the one formula or the one method that you actually might use in like everyday real life stuff, okay? So say you're in marketing and you're working at an advertising company and you plan to market a product to low income families only. A study states that for a particular area, the average income per family is $24,596. So if this is the average income, what can I label that with? Mu, right? And the standard deviation is 6256. So what can I label that with? Sigma. So the forward and backward problems, guys, you will always be given mu and sigma, okay? So that gets kind of tricky because you're like, how do I know which direction I'm going? If they say find the probability, that's when you do the forward direction and you need to find a z-score. But if they give you a percentage, they've given you a probability, and that's actually what's going to happen here. It says, if the company plans to target the bottom 18% of the families based on income, find the cutoff income. And what that means is that they're not asking you to find the probability, they're actually giving you the probability. They're giving you the bottom 18%. So what we have to realize is we're shading the bottom 18%, which represents an area that corresponds with the z-score. So let's see if we can make that happen. So we're going to draw our normal curve where our mean of 24,596 is in the middle. And then where would the bottom 18% be? Like where would my cutoff be? Pretty far to the left, right? Anything on the right would be more than 50%. This is 50%. So, I mean, the bottom 18% is not going to be very far, right? So what we have to realize is, guys, they've given us an area of 18%. So when they give you a percent, they've given you an area. If they give you a percent, they've given you an area, and that's when you have to say, okay, I got to go backwards, all right? So the question is, what z-score corresponds to the cutoff income? Well, they've given us percent, so that's when we're going to look in our chart to see how close to 0.1800 inside here we can get. What z-score is that going to be? So look for area closest to. So we can get 1841. What else can we get? 1814. but there's also 1788, okay? So remember, we're looking in here for 1800. I fly down this column real quick, and I notice 1841's pretty spot on. 1814 is even closer, and what about 1788? It's the closest, right? That is 12 below, that is 14 above. So what z-score corresponds to 1788? Negative 0.92. So the z-score is negative 0.92, and who does he go with? 1788. Do you guys see what we're doing there? So when we get 0.18, we're not given a z-score, okay? So don't go down to 0.1 and scroll over to 8, right? We're given an area, so that's when we have to go backwards and see how close we can get to that. So the area closest to 1800 was 1788. That went with the z-score of negative 0.92. That's the hardest part, because now we have everything for that formula, okay? So the backwards formula is x equals mu plus z times sigma. We labeled mu and sigma in our problem above, and we just found our z, okay? So x is going to be mu. What was our mean? 24,596 plus z, which we just found was negative 0.92, times sigma, which was labeled in our problem 6256. Bless you. Does everybody see where all those numbers come from? So they'll always give you mu and sigma. What you have to find is either the z based on the formula or the z based on the area, okay? So when you throw this into your calculator exactly like that. So throw it in, do the math, beeper, bopper, beep, okay? You'll get 18,840, and since it's money, we'll round to the nearest hundredths. So $18,840.48. And I like question 4 because I know that's like what you guys are thinking. Like, what does this mean? What did I just find? What did we just find? The cutoff income, right? Who are we targeting? The bottom 18%. So who we're going to target are people that make $18,840.48 or less, okay? So x is less than $18,840.48, all right? So the bottom 18% of incomes make $18,840.48 or less. That is the cutoff. So if you make $20,000, you would not be targeted. If you made $12,000, you would be targeted. Another way you can think of it is 18th percentile, right? You're in the 18th percentile if you make that amount. If you weren't too sure how to answer that question, go back to the actual question. Find the cutoff income. That's what we found. We found the cutoff income. Are there any questions on that guy? Okay. So again, let's look at this last one here. Sometimes you don't want the bottom or the top, you like the middle. Because it's like, you don't want to waste your time with the high-end people. You don't want to waste your time with the low-end people. So sometimes we like the middle. So if you read the top of page 10, it says, a marine dealer finds that the average price of a previously owned boat is $6,492. So what can we label 6,492 with? Mu. That was our average, right? He decides to sell boats that will appeal to the middle 66% of the market in terms of price. So what have they given us? They've given us the area of the middle 66%. Find the maximum and the minimum price of the boat the dealer will sell. The standard deviation is $1,025, and the variance is normally distributed. Or the variable. Would a boat priced at $55.50 be sold in his store? Okay. So at the top of page 10, let me catch up with you guys, and we're going to label everything. So the average price that he sells is $64.92. The standard deviation was $10.25, and the middle 66% is our area. Okay, and this makes sense. If you're a used car or boat salesman, you're not going to sell the really pricey boats, but you don't want to waste your time with the $200 boats. Okay, so you're going to target the middle. All right. So what we're going to do is we're going to draw our normal curve and shade what we care about. The normal curve uses the everyday real life values. So the mean 64.92 is going to go in the middle. And then how do we show the middle 66%? Yeah, we're just going to straddle that mean, right? And again, kind of eyeball it. 66% is roughly half. So hopefully we shade roughly half of our graph, right? So that's the middle 66%. All right? So you're done. You're like, okay, I'm shading that. That's what we care about. And so we want to get this cutoff guy here, and we want to get this cutoff guy here. So obviously our lower bound is going to be less than 6492, and our upper bound is going to be greater. The question is, how are we going to get there? Well, part 2 says, what z-score corresponds to this cutoff? Well, does this chart tell you middle areas? No. This chart only shows you areas to the left. So remember what we have to do is we have to first find the opposite of 66%. What's the opposite of 66%? 34%. Why did I do that? Because that means there's 34% in the tails total. But how many tails are there? 2. So I'm just going to take that 34% and divide by 2, and I get 17. I'm going to put 2 zeros. So that means there's 1,700 and 1,700 here. What's the only one I really care about? This lower one, right? Because if I look up the lower, that's strictly in our chart, yay! And then the upper will just be the positive version of that, okay? So look for area closest to 1,700. My 1,700 looks a little weird.
1711.
Is 1,711 the closest we can get? Let me catch up with you guys. Yes, okay? So guys, again, scrolling real quickly, you'll find 1,711 or 1,685. 1,711 is 11 over, 1,685 is 15 under. So 1,711 is a z-score of what? Negative 0.95, so that goes with 1,711. But that's just our bottom z. What's our top z going to be?
Just regular.
You got it. Just regular 0.95. So even though we have to find 2, you're really only finding 1 and making the other one the positive version of it, okay? So if there's 66% in the middle and the whole graph represents 100%, then that leaves 34% for the tails or 17% for one tail. Remember, the percents are area, so we changed them to a decimal, and we saw how close to 1,700 we could get, which was 1,711. Now what we're going to do is we're going to just use that backwards formula twice, once with the negative 0.95 to get that lower cutoff, and then once with the positive 0.95 to get the upper cutoff. Okay, so we're just going to use that backwards formula twice. So we have x equals mu plus z times sigma, and x equals mu plus z times sigma. Oops. Okay, so this will be the minimum, and this will be the maximum. All right. So what was our average boats that he sold? 6492 plus a z-score of negative 0.95 times our standard deviation of 1025. The max, guys, is going to be exactly the same, except for using the positive 0.95. So the mean is still 6492. The z is still a positive 0.95. And the standard deviation is still 1025. All right, so you can throw that in your calculator exactly as is, beeper bopper beep, round to 2 decimals, and you should get 55.18 and 25 cents. And then when you do the same for the top with the positive 0.95, you should get 74.65 and 75 cents. And again, my favorite question, what's this mean?
The dealer will sell boats between 55.18 and 25 cents.
Right, we've kind of found the cutoff prices that the dealer's selling, right? So we shaded between, so we know the lower bound's 55.18 and the upper bound's 74.65. So the dealer's selling boats between these two values, okay? So that's what X is between. But in layman's terms, we would just say the seller sells boats, or dealer, I don't know, sells boats in between 55.18 and 74.65. Okay. And once you get that answer, I can ask you 1,000 questions like number 5. If you had a budget of $55.50, could you go to his store and find something in your price range? Yeah, right? Barely, right? He's almost cutting me off on the low end. But since our low end goes to $55.18, $55.50 lies between these two values. So yes, a boat would be sold in his store for that price. Okay, and again, you don't really do this a whole lot. You'll just have a couple problems like this in 7.2 where it's backwards, but to me, it's what we do the most of. Like, if we want to like advertise to the middle 80% of people, this is how we'd go about doing it. And people do this. Statisticians, people that work for companies are able to do this and figure out, you know, the cutoffs that we're looking at. Maybe cutoff ages, whatever it may be.